After we designed our lateral, the next step is to go and design the submain. We will see that when we click the submain option, automatically all these settings that we used when calculating the lateral, the inlet pressure, the flow rate of one lateral, all this information will be automatically imported in the submain section. So let's click on submain. We see here that the flow rate of one lateral is already imported. We see the lateral inlet pressure is already imported. And we have here the option to double the flow rate in case we have laterals going both directions from the submain. So in case you have a submain and the lateral going left and right, you need to click on this option to double the flow rate that you use for calculating your submain. For our example today, we will not be using this, so I will not click this, because in our example, laterals will be going just in one direction from the submain. So let's move ahead and fill in the missing information. Let's say we want to design with an allowable head loss of 2 meters, and we want to design with a maximum velocity of 3 meters per second. This is a personal option. You can choose different values if you want to. We need to define the lateral spacing. Let's say we have 1.4 meters between the laterals, and define the submain length. So here we have two options. Either we define the number of rows. Let's say we have 100 rows, in which case the hydraulic tool will calculate the submain length, or we can input the submain length, let's say 140 meters, and the hydraulic tool will calculate the number of rows and the total flow required for this number of rows. Let's say we have a submain of 200 meters. When we input 200 meters here, we already see that we need a flow rate of almost 70 cubic meter per hour for our submain. Also here we have the option to input a distance between the valve and the first lateral. Let's say we have 10 meters from the valve to the first lateral. This will influence the head loss and the water velocity overall. But you know what, for example, let's say we have 0 here. So the first lateral is right near the field valve, as we can see here in this image. Next, we need to go and select the type of product that we want to use. For our example, we will be using a PVC pipe. The standard will be European one. And we will not be choosing a certain class. So we will not be choosing a PN6 or a PN10. We will be choosing all, so that the software will consider both options. Now, we have here the option either to calculate length. This option is to be used when you want to use just one diameter of pipe, or we can input a custom length in case we want to use a telescopic submain, in case we want to use 2 or 3 different dimensions of submain. Let's start with the first option. Now here we already start to see some values. So if in case we want to use a 40 millimeter pipe, the water velocity will be too high. So you can have a look at different diameters and test to see exactly what will be the water velocity. Let's say we want to have a look at, let's say in general we want to have a look at a 160 millimeter pipe, a 140 millimeter pipe, and a 125. Let's see we want to check what is happening with these diameters of pipe. Here we can either input the length that we want to test for each of these diameters, or in case we want the software to recommend what diameter to use, we can leave these fields blank or 0 and click on calculate, and the software will tell us. In order to fit in between these limits that we gave it, so allowable head loss of 2 meters and maximum velocity of 3 meters, the software tells us you can easily use the full length of the submain with a 125 millimeter pipe. You don't need to go to 140, 160, because 125 can fit into your demands. So the water velocity will be 1.7, the head loss will be 1.4, so this totally fits into your requirements. Let's say we want to have a look at an even smaller pipe, a 110 millimeter PN6. Delete this and click calculate. In this case, the software is suggesting that we can use 108 meters of 110 millimeter pipe and 91 meters of 125 millimeter pipe. So the software is suggesting that we can use a telescopic submain. We can click on custom length and start to play with these values on our own. Let's say we want to, because we know very well that these PVC pipes come in 6-meter pipes, so you cannot design with a 91.25 meters. So let's say we want to use just 36 meters of this bigger diameter pipe, and the rest will be 110. So 164 meters will be 110 millimeter pipe. Let's see what happens. In this case, if we want to use this option, we see that we need a pressure at the valve outlet of 6 meters. The first lateral will receive 6 meters, which is higher than we need to, so overall good. The last lateral will receive exactly 3.45 meters, which is the requirement of a lateral. And the total head loss is slightly bigger than we set it. So in this case, we can either choose to use this option or place with some values some more until we get the 2 meters head loss that we want. We see also that the graphic part here on the right is updating. So we still have the lateral inlet pressure, lateral end pressure, valve outlet pressure, submain head loss. So the submain is losing 2 meters. And later on, when we start calculating also the main line and the system summary, we will see that all these values here will start to populate with real values of pressure. Like we showed in the lateral section, we can also add some slopes. So let's say that from our 200 meters, we have 50 meters of 2% slope uphill. And let's say we have 100 meters of 1% downhill. After we input this information, we go back here and click again, calculate. And the hydraulic tool tells us that with these slopes, we will need this outlet pressure at the valve. The submain will lose less pressure because it's a lot of downhill slope here. So anyway, the downhill slope is bigger than the uphill slope. And these values change. So now we need a different pressure at the valve outlet. We have a different head loss. The first lateral will receive lower pressure. And that's about it. You can delete the slopes now if you want and go back to the initial calculation where we needed 5.8 meters at the valve outlet. In this case, we are simulating a flat terrain. Close the slopes, and that's it.